Hello everyone, and welcome. In this video, we'll be diving into the world of Power BI, focusing specifically on one of the most important concepts, conditional formatting. This session is brought to you by ZoomInData, your space for learning business intelligence and data analytics. So, let's get started and understand how Power BI connects to different data sources and why this process is so essential in today's data-driven world. First question: what is the difference between conditional formatting by rules, by color scale, and by field value, and when should each be used? By rules applies formatting based on explicit logical conditions. For example, greater than 90 equals green. It is used when you need full control over thresholds. By color scale applies a gradient based on minimum-maximum values and is used for continuous data such as scores or sales amounts. By field value uses a measure or column that returns colors or hex codes, ideal for dynamic or DAX-driven formatting. Choose based on whether you want manual control, automatic scaling, or DAX-driven flexibility. Second question: can conditional formatting be applied using a field that is not present in the visual? Explain with an example. Yes, Power BI allows formatting based on a field not displayed in the visual. For example, you can color product sales using a separate profit margin measure even if profit margin is not shown. This is useful when you want the visual to stay clean but still indicate performance through color. The field must simply be compatible with the formatting, numeric, text, or hex depending on type. Third question: how does conditional formatting behave differently for columns versus measures? Columns have fixed values stored in the data model, so formatting is stable and unaffected by slices. Measures recalculate based on filter context, so formatting dynamically changes with slices and interactions. Measures allow advanced logic, example YOY, rankings, while columns provide static row-by-row formatting. Measures may cause unexpected colors if the context changes drastically. Fourth question: how does conditional formatting react when slices dramatically change the data distribution? Color scales recalibrate their min-max values, potentially changing the meaning of colors. Rules remain stable, but values may fall into different rule ranges after slicer changes. Measures used for formatting can return different results due to altered filter context. In extreme filtering, the visual may show only one color if the range collapses. Fifth question: why does conditional formatting sometimes not apply to totals or subtotals in matrices? Totals use a different filter context than individual rows, often returning aggregate values that don't match formatting rules. Data bars and icons usually do not apply to totals because Power BI formats only row-level data. Measures used for formatting may return blank, or unexpected values at total level. Power BI intentionally avoids applying certain visual cues to totals to prevent misleading interpretations. Sixth question: what is the performance impact of applying complex conditional formatting to large direct query datasets? Each conditional formatting rule often triggers an extra query to the data source. Complex DAX logic increases back-end computation time and slows visuals. Large fact tables combined with color scales or row-level logic can significantly increase refresh times. Using measures for formatting in direct query models can cause noticeable rendering delays. Seventh question: explain a situation where conditional formatting gives the wrong color due to filter context. When a measure depends on calculate modifiers, slices may change its output unexpectedly. For example, a percentage of total sales measure behaves differently when a category slicer filters out other categories. All selected may change totals depending on which visuals or slices are active. As a result, a value might appear above the threshold logically but fall below after filters are applied. Eighth question. What happens to conditional formatting when the measure returns blank? Blank usually results in no color, meaning Power BI leaves the cell unformatted. Icons or data bars do not appear because they require numeric values. Color scales treat blank as outside the range, often defaulting to white or transparent. This is useful for intentionally hiding formatting under certain conditions. Ninth question. How does conditional formatting interact with row-level security, RLS? RLS changes the visible data, so all conditional formatting recalculates based on the restricted dataset. Color scales may shift because min-max values differ for each RLS role. Rules still apply, but values may fall into different ranges due to filtered results. RLS can cause formatting to appear inconsistent across users because each user sees different slices of the data. 10th question. Why can conditional formatting break when using all selected in the formatting measure? All selected depends on external interactions, slices, visuals, so the min-max logic may behave unpredictably. When no selection exists, all selected returns the full dataset. With selections, it returns a subset, altering results. If used in color logic, color outputs may become unstable or inconsistent. In some cases, all selected may return blank, causing formatting to disappear. 11th question. What is the difference between built-in icon sets and custom icons created using image URLs? Built-in icon sets are predefined by Power BI, arrows, circles, bars, and require no external files. They are easy to configure, fast to render, and optimized for performance. Custom icons use external image URLs or base64 encoded images, allowing complete design flexibility such as branded icons, emoji-style indicators, or KPI symbols. Built-in icons automatically scale well, follow Power BI themes, and support accessibility settings like color-blind-friendly designs. Custom image URLs rely on external hosting. If the URL breaks or loads slowly, the visual may show blank icons. They also require measures that return URLs rather than numeric thresholds. 12th question. How do you build icon logic using a DAX measure with Switch? You first create a DAX measure that evaluates conditions and returns numeric buckets, like 1, 2, 3, or directly returns image URLs. The switch function allows clean, readable logic compared to nested if statements. For example, icon logic is equal to switch, true, sales is greater than 100,000, 1, sales is greater than 50,000, 2, 3. This measure maps the result to icon thresholds in the conditional formatting panel. Using switch ensures the formatting remains maintainable, predictable, and easier to extend when new logic or conditions are introduced. 13th question. How do icon sets behave when the underlying measure changes dynamically due to slices? Icon sets recalculate based on the measure's updated value after slices modify the filter context. This means an item showing a green up arrow may change to a yellow dash or red down arrow, when the user selects a different region, product, or date range. If the visual is heavily dependent on comparator measures like year-over-year or growth percentage, slices can drastically shift the icon categories. In some cases, icons may disappear if the underlying measure returns blank due to slicer filters removing all related data. 14th question. What happens if two icon thresholds overlap? When thresholds overlap, for example, both rules include the value 50, Power BI evaluates conditions from top to bottom. The first matching condition gets priority, meaning the lower rules may never get applied even if they are logically valid. This can lead to unexpected icon colors because users assume all rules are evaluated independently. To avoid this, thresholds should be mutually exclusive and structured clearly. For example, using strict greater than or strict less than rather than greater than or equal to or less than or equal to on both sides. 15th question. How can icons be displayed only when a specific slicer value is selected? Icons can be displayed conditionally by creating a formatting measure that checks the slicer selection using functions such as selected value or is filtered. For example, icon visible is equal to. If the selected value from the field period type is equal to current month, then return the icon logic measure, otherwise return blank. When the condition is not met, the measure returns blank, which causes Power BI to hide the icon. This method is commonly used to show icons only for selections such as current period, top N, or active status. 16th question. Why might icon sets behave differently in direct query versus import mode? In direct query, every evaluation of a measure or formatting rule sends a query back to the database, which may introduce delays or inconsistent responses. Complex icon logic involving multiple case or switch conditions can be slowed down depending on database performance. Some SQL sources handle logical comparisons differently, causing thresholds or conditions to behave inconsistently compared to import mode. In contrast, import mode evaluates everything in memory, ensuring consistent icon rendering and faster performance. 17th question. How does Power BI calculate the minimum and maximum bar length for data bars? Power BI automatically determines the bar length by mapping each value between the minimum and maximum of the column or measure. The smallest value gets the shortest bar, and the largest gets the longest. When slices filter the data, the min-max range recalculates dynamically, which can change the bar proportions. You can optionally override min-max values manually to force consistent scaling across visuals or time periods. The visual uses a proportional linear scale, meaning bar length is directly tied to the relative value, not the absolute number. 18th question. How do you handle data bars when the dataset contains both positive and negative values? When both positive and negative values exist, Power BI places 0 at the center, and bars extend left for negatives and right for positives. Negative bars are usually displayed in a different color, often red, but you can override this using formatting options. To avoid confusion, many developers use separate measures, e.g., positive only and negative only, so that bars remain unidirectional. You can also apply conditional formatting logic via DAX to treat negative values differently, such as hiding bars for small negative values. 19th question. Why can data bars give a misleading visual interpretation for percentage-based fields? Percentage fields often have a very narrow range, example 82 to 89%, causing the bars to look almost the same length even though the differences may be meaningful. The visual exaggerates small differences because it scales bars relative to the min-max values, which may not reflect real-world impact. Users may incorrectly interpret small visual bar differences as large performance gaps. Setting manual min-max values, example 0% to 100%, helps maintain consistent interpretation but may make small changes hard to notice. 20th question. How can a measure be used to dynamically change bar colors? A DAX measure can be created that returns a hexadecimal color code such as #FF0000 based on conditions like thresholds or key performance indicators. This measure is then applied through conditional formatting under data bars using the option Format by Field Value. Based on the business logic, the measure can change colors dynamically according to slicer selections, user roles, or time periods. This method offers greater flexibility when compared to static color settings and allows implementation of advanced business rules. 21st question. What are the key limitations of data bars in Power BI? Data bars cannot be applied to matrix totals or subtotals, which reduces consistency across hierarchical visuals. They support only horizontal bars and cannot show icons, labels, or multiple metrics within the bar. Custom colors are limited, and gradient or multicolor bars are not supported directly. They can cause performance issues in direct query models, especially with large datasets or complex underlying measures. 22nd question. Why do data bars not appear for totals in a matrix? Totals use a different filter context that aggregates values, and Power BI restricts data bars to row-level data only. Displaying bars at total level may be misleading because totals don't follow the same min-max logic as individual rows. The engine treats totals as group summaries rather than individual data points, so formatting rules designed for rows don't apply. This limitation is intentional to prevent incorrect visual interpretation of aggregated values. 23rd question. When should you use a diverging color scale versus a sequential one? Use a diverging color scale when your data has a meaningful midpoint, such as 0, target value, or national average. It helps highlight values above and below the midpoint distinctly. Diverging scales are ideal for KPIs, variance, sentiment, performance against target, and positive, negative metrics. Use a sequential color scale when data progresses from low to high without needing a central reference point. Sequential scales work best for continuous values like sales amount, population, or scores. 24th question. How does Power BI automatically determine the midpoint when applying a three-color scale? Power BI sets the midpoint to the median of the data if no custom midpoint is defined. This ensures that half the values fall above and half below, giving a balanced color distribution. After slicer changes, the median recalculates, causing the midpoint color to shift dynamically. If the dataset contains many identical values, Power BI may push the midpoint to the nearest distinct value to maintain contrast. 25th question. How can you create a percentile-based color scale in Power BI to avoid distortion from outliers? You can create DAX measures using the functions percentilex.inc or percentilex.exc to calculate the 5th percentile and the 95th percentile, instead of using the raw minimum and maximum values. These percentile values act as more stable boundaries, so that extremely high or extremely low outlier values do not stretch or distort the color range. After creating the percentile measures, you apply them in conditional formatting by choosing Format by then field value and assigning the 5th percentile measure to the minimum setting and the 95th percentile measure to the maximum setting. This method produces a more realistic and evenly distributed color gradient, which is especially helpful when working with business datasets that are skewed or contain extreme outliers. 26th question. How do color scales behave when the dataset is skewed or contains outliers? A few extreme outliers can stretch the color scale, causing most values to appear with very similar colors, reducing visual differentiation. In a heavily skewed dataset, even small changes among clustered values may not reflect clearly due to compressed color ranges. To handle this, developers often cap min or max values or use percentile-based DAX logic to prevent distortion. Outliers can make midpoints misleading, especially in diverging scales, because they shift the median or average used for automatic midpoint calculation. 27th question. What is the difference between using a manual rule and using a DAX-based measure for conditional formatting? Manual rules use fixed thresholds. For example, value greater than 1000 gives green color. These rules are simple to set up, but they do not change automatically when slices or filters change. A DAX-based measure, on the other hand, calculates colors or thresholds dynamically based on the filter context, slicer selections, or business conditions. Measures can handle advanced logic such as top-N rankings, year-over-year changes, and dynamic targets, which manual rules cannot do. In summary, manual rules are static and remain the same always, while DAX-based rules are fully dynamic, flexible, and scalable across different visuals. 28th question. How do formatting measures behave when the DAX uses time intelligence functions like MOM or YOY? MOM or YOY functions depend heavily on date context, so slices and visual filters directly affect the result and thus the formatting color. If the selected period does not have prior period data, these functions may return blank, causing formatting to disappear. Formatting may shift dramatically when comparing across different time frames, creating dynamic color changes. Incomplete date hierarchies or missing dates can lead to incorrect or inconsistent formatting. 29th question. Why does conditional formatting sometimes fail when Show items with no data is turned on? When items with no data appear, the measure used for formatting often returns blank, which prevents color or icon application. Power BI cannot apply formatting without a value, so the cell remains unformatted. Filters may cause some categories to show zero or blank values, which can break measure logic designed for non-empty rows. Inconsistent filter context between displayed rows and actual data may also lead to unexpected formatting gaps. 30th question. Why is switch generally better than nested if conditions for formatting logic? Switch with true provides cleaner, more readable, and more maintainable code, especially when you have many conditions. It reduces logical errors because each condition is checked in order, similar to how case statements work. Switch also performs better in complex DAX scenarios because it avoids deep nesting, which can slow down calculations. It makes it easier to add or change formatting rules without breaking the existing logic. Thank you for watching this session. If you have any questions, you are welcome to contact ZoomInData through our website, email, or phone. We're always here to support your learning journey. See you in the next video.